Okay, assalamu alaikum. Today we need to start chapter 7. Chapter 7 is about matrices or matrix algebra, which is a little bit different from chapter 6. Chapter 6 was about vectors, but we are still in algebra, but another topic, which is matrices. So I think you learned before about matrices, but here we will revise again some of the concept that you already studied before. What is the meaning of matrices? What is the elementary row operations? How to find the determinant of a matrix? How to find the minor? How to find the cofactor? How to evaluate the cofactor expansion? Then we will learn how to find the inverse of the matrix in case that the matrix have inverse. And we have two methods that we need to learn how to find the inverse using ERO, elementary row operation, or using adjoint method. Then we will learn how to solve a system of linear equations using matrices, either by Gauss elimination method or Gauss-Jordan elimination method or inverse matrix method or Cramer's rule. Then finally, we will learn about eigenvalues and eigenvectors and how to find the eigenvalues and eigenvectors. So let's start by the definition of a matrix. What is the meaning of the matrix? A matrix is arrangement of the number. We have a row, we have a column here. This arrangement of the number, we call it a matrix. The matrix M times N means that it has M rows and N columns. We have M rows from 1 until M times N columns. When we say that A to N, this is meaning this is the element in the second row and column. Second row and column. A11, first row, first column. A12, first row, second column. AM2, the M row, the mth row, two or second column. So the first number represents the number of the row. The second number here represents the number of the column. Then we can denote the matrix by Aij M times and Aij, the element in the ith row, jth column, M times N, the number of the rows in the matrix, the number of the column. And we have elementary row operations that we can do in the matrix. If we do these operations in the matrix, we can have equivalent matrix, our matrix, not equal, but equivalent. I mean, the two matrices still considered as same matrix, or equivalent matrix. Three types of operations that we can do. First, we can interchange, or we can replace one by another. The rows, we can interchange between two rows. We can interchange row 1 by row 2, or by row 2 by row 3, row 3 by row 2. You can interchange any two rows. Or you can multiply the ith row of the matrix with a scalar. You can take for any row and multiply this row by a scalar, also can. Or doing both. Multiply one row by a scalar, adding to a second row, adding to another row. These three operations, if it is conducted on the matrix still same. For example, if I have the matrix 2, 5, 3, 1, 2, 1, minus 3, 1, 2. This is a matrix 3 by 3. I have 3 rows, 3 columns. I need to do these operations on the matrix. The result will be the equivalent matrices. The results will be equivalent matrices. So if we start 2, 5, 3, 1, 2, 1, minus 3, 1, 2. First, I need to change row 1 by row 2. I need to change the first operation here. We need to change row 1 by row 2. So I will make row 2 is the first row, and the first row will be the second row. So here, I will change row 1 by row 2. So the result will be 1, 2, 1. Now the second row becomes the first. 2, 5, 3, minus 3, 1, 2. Minus 3, 1, 2. Then I need to multiply the first row by minus 2, adding to the second row. I will multiply the first row by minus 2. Then I will add to the second row. I will multiply the first row by minus 2, adding to the second row. 1, 2, 1. Now multiply minus 2. Here minus 2 R1 plus R2. Okay. Minus 2. Minus 2 times 1 plus 2, 0. Minus 2 times 2 plus 5 means 1. Minus 2 times 1 plus 3 means 1. 3 minus 2 also 1. So 0, 1, 1. The second row now becomes 0, 1, 1. The third row keeps same. So what I did here, I multiply the first row by second 2, adding to the second one. Minus 2 times 1 minus 2 plus 2, 0. Minus 2 times 2 minus 4 plus 5, 1. Minus 2 times 1 minus 2 plus 3 is 1. And the third row is minus 3, 1, 2. Now I will perform the third operation. I will multiply the first row by 3, adding to the third. Multiply the first row by 3, adding to the third. So here we have 3 first row plus third. Okay. You have 1, 2, 1, 0, 1, 1. Okay. 3 times 1 is 3, minus 3 is 0. 3 times 2, 6, plus 1 is 7. 3 times 1 is 3, plus 2 is 5. So here I multiply the first row by 3, adding to the third. 3 times 1, 3, minus 3, the result is 0. 3 times 2 is 6, plus 1, the result is 7. 3 times 1 is 3, plus 2, the result is 5. So 0, 7, 5. Here, note that the operation that I did until now give me 1 here. Below this one, I have 2 zeros, 0 and 0. Okay, now the next operation, I need to multiply the second row this time by minus 7, adding to the third. The second row by minus 7, adding to the third. So 1, 2, 1, 0, 1, 1. Okay. Minus 7 times 0 plus 0 is 0. Minus 7 times 1 minus 7 plus 7, another 0. Minus 7 times 1 minus 7 plus 5 minus 2. So I multiply this row by minus 7. So we have minus 7 times 0, 0. Plus 0, still 0. Minus 7 times 1, minus 7. Plus 7, 0. Minus 7 times 1, minus 7. Plus 5 is minus 2. Now the third step, or now I have another one. Below this one, I have 0. The last operation, I will divide the third row by minus 2. You can multiply any row by a scalar. We can change between the row. We can multiply a row by a scalar adding to the third. So 0 over minus 2, 0. 0 over minus 2, another 0, minus 2 over minus 2 is 1. So this matrix is equivalent to the first matrix, this one. These two matrices are equivalent. The operation that we did, we can change between two rows as we did the first time, or the first operation. You can multiply any row by a scalar. R1 multiplied by minus 2, R2 multiplied by minus 7. We multiply R1 by 3 again. We divided R3 by minus 2, or multiplied by 1 over minus 2. You can multiply by any non-zero scalar. You cannot multiply by 0. You can multiply by any non-zero number. And you can adding to another row. Not only multiply, after you multiply, you can add to another row, as we did here. So this matrix is still equivalent. This matrix is still equivalent. A is equivalent to B. Now we have what we call it row echelon matrices, or row echelon operation. Okay, to say that the matrices in row echelon matrix, it should satisfy 4 conditions. First, if there is any, at least should be I have non-zero row. I mean, not all the matrix is 0, because this is, we call it a 0 matrix. It should be at least one number, not 0, inside the matrix. At least one row is non-zero. At least one number inside the matrix, non-zero. The second condition, the first number or the first non-zero number in each row should be 1. The first non-zero number in each row should be equal to 1. We call it the leading one. The third condition, the leading one in the lower row should become to the right from the upper one. The leading one in the lower row should be coming to the right from the upper row. The fourth condition should be if there is a row with all 0, will be entirely all zeros. I mean, all the component of this row 0, it should become at the bottom of the matrix. Should become at the bottom of the matrix. If the matrix satisfied these 4 conditions, we call it is in row echelon matrix, or in row echelon form. If we add another one condition, I mean we satisfy the first row, the first 4 condition, and the fifth condition also satisfied, we call it row reduced echelon form, which means that it should be row echelon form. But if it is satisfied this fifth condition, it will be reduced row echelon form. This one, that, or the fifth condition, I have only 1 and all the other numbers is 0. I have the leading ones and all the other numbers are 0. For example, here, this matrix. Okay, the row that have zeros is at the bottom of the matrix. This is the first condition. The row that have 0 at the bottom of the matrix. We have non-zero row. I have here 2 row with non-zero components. I mean, I have 1, 4, 2, 1. These 2 rows, including numbers that are non-zero. Only 1 row, all is 0. So the second condition satisfied. Okay, the first non-zero number is 1. The first non-zero number is 1. Here also in the second row, the first non-zero number is 1. So in each non-zero row, the first number or the first non-zero number is 1. The non-zero number in the second row come to the right from the leading one in the first row. Because this we call it the leading one. The leading one. So the leading one in the second row come to the right from the leading one in the first row. So this matrix in row echelon form. This matrix in row echelon form. Okay, this is another example B. Here we have some rows that are non-zero. The first non-zero number is 1 in each row. The first non-zero number is 1. 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 Okay, so these are the leading ones. Each leading one come to the right from the previous one. Okay, this is the leading one. This second leading one come to the right. Then the third leading one come to the right from the second one. And the last leading one also come to the right. So we have each leading one come to the right from the upper one. Come to the right from the upper one. So this matrix as well in row echelon form. This matrix we obtain here also in row echelon form. Because we have first non-zero number is 1. The first non-zero number in each row in 1. Each one come to the right to the previous one. Each one come to the right for the previous one. So this is in row echelon form. In row echelon form. Okay. This one in row echelon form as well. The first non-zero number is 1. The first non-zero number is 1. Each one come to the right from the previous one. This one come to the right. This one come to the right from the previous one. Another example is here. The first non-zero number is 1. Second row, the first non-zero number is 1. This leading one come to the right from the previous one. The row with having 0 entries or entirely all 0 come at the bottom of the matrix. Okay. Okay, this one in row echelon form, also this one in row echelon form. But this one, number C here, and D, C and D are in row echelon form and also reduced row echelon form. Not only row, but also reduced. Why reduced? Because the column that have leading 1, the other entries are 0. For example, this leading 1, all the other numbers in the same columns are 0. So 1, 0, 0. This is another leading 1. The other numbers in the same column is 0. This is a leading 1. The other numbers in the same column are 0. So this is not only row echelon form, this is also reduced row echelon form. This one also reduced because the leading one here have 0 and 0. The leading one here have 0 and 0. So this is reduced. The fifth condition also satisfied. So these two reduced row echelon form. These two not reduced because the leading one here have entry 4, not 0. So this is row echelon form, yes, but not reduced. Here same, the leading one 0. The second leading one have 2. So this means this is in row echelon form, but not reduced. If reduced, all the other numbers in the column that have leading 1 should be 0. All the other number, each column that containing a leading 1 has 0 everywhere else. Okay, so A and B only row echelon form, but not reduced. C and D in row echelon form and also reduced. Okay, let's check these together. Okay, the first one, the matrix A here. Is it row echelon form or not? matrix A. Is it row echelon form or not? Not. Why? Why not? Which condition not satisfied? Yes, exactly. The issue, okay. Let's check one by one. The first non-zero number in each row is 1. Okay, we have 1, 1, 1. The first non-zero number is 1. But the issue, this leading 1 should be come to the right from this one. But it come to the left. So we cannot, the leading 1 here, the 1 in below should be come to the right, not to the left. So this is not in reduced row echelon form. This is not in reduced echelon form. So how to make it in reduced echelon form? What we need to do to convert this matrix to row echelon form? Yes, switch R1 and R2. You need to replace R1 and R2. Okay, matrix B. Is it in row echelon form or is it row echelon matrix or not? Matrix B. Matrix B. Is it in row echelon matrix or not? Where are the others? Is matrix B in row echelon form or not? Okay, what about the others? Is it row echelon matrix? Lena said yes. What about the others? Do you agree or not? Is it row echelon matrix or not? No, actually, no. Not reduced. No, no, no. Because, okay, the first condition, not reduced. No, no, not reduced. Because you have this row with full 0. This row should be at the bottom of the matrix. Yes, the first non-zero number is 1 and it come to the right. I agree with you. But the fourth condition that any row, including all 0, should become at the bottom of the matrix. So this is in this form, not in reduced row echelon form. You need to replace. Make this one the first row, this one the second row, this should be the last. This should be R3. If you have a row that all 0, it should become at the bottom of the matrix. Like this one. Like this one. Here, this one. It should be, this is the fourth condition. If there are any row that consist entirely all 0, they are grouped together at the bottom of the matrix. So this condition here not satisfied. So this is not row echelon matrix. You need to replace. Make this one R1, this one R2, this one R3. So you need to change. You need to change R1, R2 by R3 first, then another switch between R2 and R3 again. So this will become the first, this is the second, this is the third. Okay, C. Is it row echelon matrix or not? Is it row echelon matrix or not? C. What do you think? Row echelon matrix? Yes, not. Not row echelon matrix. Which condition not satisfied? Which one not satisfied here? Condition 3. Yes, correct. Okay, the first non-zero number is 1. This is the first leading one. The first non-zero number here is 1. Come to the right. The first non-zero number here also 1, but not come to the right. It come below. It come below the first. This leading one come below the second leading one. Cannot. It should be come to the right. Should be, this one should be 0. This number should be equal to 0. So this is not in row echelon form. How to make it row echelon form? You need to subtract R1 minus R2 to convert this one to 0. Sorry, R2 minus R3. R2 minus R3. Then you have this one will become 0. This one will become 0. Because you cannot leading one should become to the right from the previous one, not under the previous one. Should become to the right. Also not. D. Is it row echelon matrix or not? 1, 10, 0, 0, 0, 1, 1, 0, 0, 0, minus 1. Row echelon matrix or not? D. What do you think? Is it row echelon matrix here or not? 1, 10, 0, 0, 0, 0, 1, 0, 0, 0, 0, minus 1. Also not. Why not? Which condition not satisfied? Which condition not satisfied? When you say not row echelon matrix. Condition 2. The first non-zero number should be 1. This is 1, this is 1, but this is not 1. This is minus 1. This one minus 1. So to make it row echelon form, you have to divide row 3 by minus 1, or have to multiply row 3 by minus 1 to make it in row echelon form, because currently not. Okay, E. Is it row echelon matrix or not? 1 minus 2, 0, 0, 0, 0, 1, 4. Here all 0. Okay, this one, yes, row echelon matrix. The first non-zero number is 1. Come to the right from the previous one. The row with 0 is below. So this is row echelon matrix. Okay, if it is row echelon matrix, is it reduced or not? Now it is row echelon matrix. Okay, but we need to go for the second question. Is it reduced row echelon matrix or not? Because if row, we need to check the fifth condition to see it is reduced or not. So this matrix, we agree it is row. Now, is it reduced? Why not? Why not reduced? Why not reduced? Yes, there is another number, not 0, but this is not on the same column of leading 1. Okay, the condition is you need to check only the column that have leading 1. So here I have leading 1, the others are 0. This column don't have leading 1. So we didn't check that one. Check only the column that have leading 1. So this I have leading 1, the others 0. I have leading 1, the others are 0. So this is in reduced row echelon form. Only check the column that have leading 1. Okay, the column that have leading 1 should be the others are 0. But this row or this column minus 2, 0, 0, not having leading 1, so it's okay. 0, 4, 0, not having leading 1, so it is okay. The issue in the first column having leading 1, so the other entries should be 0. The third column have leading 1, the other is 0. So this is, yes, in reduced row echelon form. It is not only row echelon form, but also it is reduced row echelon form. Okay, matrix F, row echelon form or not? Matrix F. And then, yes, row echelon form. The first non-zero number is 1. Each one come to the right from the previous one. The row with 0 is at the bottom. So this is row echelon matrix. Okay, is it reduced? Yes, reduced because the column that have reading 1, the others are 0, so reduced. Okay, G. Is it row echelon form? This one. Matrix G. Is it row echelon form? Matrix G. Yes, row, because we have the first number is 1 in each row. Each one come to the right. Each one come to the right. So this is row echelon matrix. Okay, the second question. Is it reduced or not? Yes, it is not because here I have 2. Okay, so the leading one here, the others are 0, okay. But the second leading one have 0 and 2. So this is not reduced. So not reduced row echelon matrix. Okay, matrix H. 1, 0, 1, 1, 0, 0, 1, 0, 1, 0, 2, 0, 0, 1, 3. This is row echelon matrix or not? Matrix H. Is it row? I think row echelon matrix. Okay, the first non-zero number is 1. Each one come to the right. Each one come to the right. Okay, reduced or not? Yes, also reduced. Reduced row echelon matrix. Because all the column having leading 1, all the other entries are 0. Okay, matrix J. Is it row echelon matrix or not? Not. Why not? Why not row echelon matrix? Which condition not satisfied here? Which one not satisfied? Why not row echelon matrix? Number 3. Uh, number 3. Number 3, each one come to the right. Okay, actually the first row don't have leading one. The first number is -1. The first non-zero number is -1. So mean that this is not a leading one. It should be 1. The first non-zero number in each row should be 1. Should be equal to 1. So here, okay, this 1, I have leading 1 here. The first non-zero number is 1. I have another leading 1. But this one is -1. So we need to make it row echelon form, you have to multiply the first row by -1. By -1. So not row echelon matrix. Matrix K, is it row? We have the first non-zero number is 1. The first non-zero number is 1. Each one come to the right, so row echelon matrix. This one row echelon matrix. Okay, is it reduced? Yes, row but not reduced. Because we have a leading one with 0 here. Also, this leading one have 0. So not reduced. Echelon matrix. Not reduced echelon matrix. So we have 2 times the row echelon matrix and reduced row echelon matrix. Okay, the rank of a matrix. We say that the rank of a matrix, before we determine the rank of the matrix, we need to convert the matrix either to echelon matrix or reduced echelon matrix. The rank of the matrix is the number of rows that is non-zero in the echelon matrix or reduced echelon matrix. Means that if your matrix not in echelon form, not in reduced echelon form, you have to convert it first to echelon matrix or reduced echelon matrix, then you can find the rank. Then you can find the rank. The rank is how many leading one you have. The rank of the matrix, how many leading one you have. For example, here, I have 3 leading one. 1, 1, 1 means that the number or the rank is 3 because leading one here, leading one here, leading one here. This matrix here, the rank also 3 because I have 3 leading one. So count the leading one, you can find the rank. Okay, this matrix, how many leading one you have? What is the rank for this one? 3. Yes, exactly. Count the number of leading one. Okay, this one, 1, 2, 0, 1, 0, 0. The rank here equal to 2. The number of leading one is 2. Okay, for this one, same. You have this is the leading one, this is leading one, this is leading one, 3. Here is 2. Here is 2. So the number of leading ones is the rank of the matrix. This is why if your matrix not in row echelon form, we need to convert it first to row echelon form, then we can find the rank of the matrix. So how to convert any matrix to row echelon form? We need to apply ERO operations, elementary row operations. We need to apply the elementary row operation. Means either you need to change the rows, the place change between the rows, or you can multiply any row by a number, or you can multiply any row by a number, adding to the another row. So applying this operation, you can convert any matrix to row echelon matrix or reduced row echelon matrix. Okay, let's go for example. I have this matrix 1, 2, 3, 2 minus 3, 2, 3, 1, 1, 3 times 3 matrix. This one not in row echelon, not in row echelon form, not echelon matrix. So I need to convert the echelon matrix or the equivalent echelon matrix for the matrix A and also the reduced echelon matrix. Mean that first I will convert it to row echelon matrix. Then I will continue until to convert reduced row echelon matrix. Then I need to find the rank. I need to find the rank of the matrix. Okay, so I have here 1, 2, 3, 2 minus 3, 2, 3, 1 minus 1. Okay, the first step to convert any matrix to row echelon matrix or reduced row echelon matrix, if you have any row includes all zero, entirely all zero, I mean any zero row should become at the bottom of the matrix. This is the first step. If you have, for example, if this matrix, if instead of 1, 2, 3, I have 0, 0, 0, this one should become at the bottom. This is the first step. Okay, this is the first step. But here I don't have, so no need for this step. But in case your matrix has a row of 0, the first step you need to make the row of 0 at the bottom of the matrix. Okay. Second step, the first row should start by 1. The first row should start by 1. If not, you have to divide by the number. For example, if my matrix start by 3, 3, 2, 3, I have to divide the first row by 3 first. I have to divide the first row by 3. But here I also already have the first number is 1, so no need. So the first step and the second step here no need to be done. If you have any row, all 0 should become at the bottom. This is the first step. Second step, the first non-zero row, the first number should be 1. The first number should be equal to 1. So here already ready. The first number on the first row is 1. Okay, now I need to go to the third step. My matrix ready to go for the third step. Okay, the third step, okay, I already have a leading 1. What I need to do, I need to make the numbers below the leading 1, 0. The number below the leading 1, 0. So I have leading 1. Below the leading 1 should be 0. This one should be 0. So here 2 should be converted to 0. 3 also should be converted to 0. How to do this one? I need to use the leading 1. The first row have leading 1. So I will multiply the first row by minus 2, adding to the second. Adding to the second. I need to convert this 2 to 0. So I will use the leading 1 here. So I will multiply the first row by minus 2, adding to the second. So minus 2 plus 2 will become 0. Minus 2 times 1 is minus 2. Plus 2 will be 0. So this is the operation that I will do. Minus 2, the first row, plus the second row. Same here to convert 3 to 0. I will multiply the first row by minus 3, R1, adding to R3. Adding to R3. So what I have, 1, 2, 3. Okay. Minus 2 times plus 2 is 0. Minus 2. Now I'm multiplying the first row by minus 2. So minus 2 plus 2, 0. Minus 2 times 2, minus 4. Minus 4 minus 3, minus 7. Minus 2 plus 3, minus 6. Minus 6 plus 2, minus 4. Minus 6 plus 2 is minus 4. Now the third row. The third row, I will multiply the first row by minus 3 adding to the third. So minus 3 times 1 minus 3 plus 3, 0. Minus 3. Now I'm working for the third row. Third row, this operation. Minus 3 multiplying by the first, adding to the third. Minus 3 times 1 minus 3 plus 3, 0. Minus 3 times 2 minus 6 plus 1 minus 5. Minus 3 times 3 minus 9. Minus 9 minus 1 is minus 10. Is minus 10. So the first step now I have 1, and below the 1 I have 2 zeros. 0 and 0. So first we be sure that the first number in the first row is 1. So I have the first leading 1. Then I need below the leading 1 should be 0. Below the leading 1 should be 0. So minus 2, how to convert 2 to 0? Use the leading 1. Multiply the leading 1 by the negative of the number. Multiply the leading 1 by the negative of the number. I have 2. I will multiply the leading 1 by minus 2. So the first row multiplied by minus 2 adding to the second. I have a 3. Multiply the leading 1 by minus 3. So the first row multiplied by minus 3 adding to the third. So minus 3 plus 3, you have 0. Now I will repeat again for the second leading 1. Now the second row should start by 1. The second row should start by 1. So I need to divide the second row by minus 7. By minus 7. So you have 1, 2, 3, 0, 1, 4 over 7, 0 minus 5 minus 10. 0 minus 5 minus 10. Now I divided the second row by minus 7. Now below the leading 1 should be 0. Means that I have to convert the 5 here or minus 5 here to 0. To convert this one to 0, you need to multiply the second row by 5. I need to use this leading 1 now, because this leading 1 below should be 0. So use the same leading 1. I have minus 5, multiply this leading 1 by 5. So what means that I need to multiply the second row by 5, adding to third. The second row by 5, adding to third. So 1, 2, 3, 0, 1, 4 over 7. Okay. I have 5 times 0 plus 0, still have 0 here. 5 times 1 is 5 minus 5 becomes 0. Now 5 times 4 over 7, which means 20 over 7, minus 10. Minus 10, which become how much? Minus 50 over 7. Omar already counted. Okay. Minus 50 over 7. Okay. 20 minus 70. Yes, minus 50. Okay, minus 50 over 7. Now I have another leading 1 below 0. So the third step, I need to convert this one to 1. I need to prepare the third leading 1. So I have to divide the third row or multiply the third row by 7 minus 7 over 30 third row. So you'll have 1, 2, 3, 0, 1, 4 over 7, 0, 0, 1. 0, 0, 1. Now I have a matrix in row echelon matrix. The first row is 1. Each one come to the right. So now in row echelon matrix, we already have in row echelon matrix. This one is row echelon matrix. Row echelon matrix. Now, if you need to continue to reduce row echelon matrix, I have to continue to reduce row echelon matrix. Means that each leading one, the other numbers should be 0. So the first leading one below is 0. Now the second leading one have 2 here, not 0. So it should be become 0. Should be become 0. To do this, I need use the same leading one in the same column. So 2 here with this leading one. So to make it 0, you need to multiply the row including leading one by -2, adding to the first. So to multiply the second row by -2, adding to the first row. Adding to the first row. So we here -2 times 0 plus 1, we still have 1. -2 times 1 -2 plus 2, we have 0. -2, 4 over 7, which means -8 over 7 plus 3. -8 over 7 plus 3. Which I think 11 over 7, if I'm not mistaken. Okay, then 0, 1, 4 over 7. 0, 1, 0, 1. Or 13 over 7, right? Should be 13. Okay. I multiply. I need to convert this one to 0. So you need to multiply the one that have leading one by the negative of the number. So -2 will be multiplied by the second row, adding to the first. Now it's still not in reduced because I still have leading one, the other two numbers not 0. So we need to convert these two to 0 as well. We need to convert these two to 0. How to make this one? I will use the leading one here. I will use the leading one here. So minus, I will do two operation. -4 over 7 R3 plus R2 -13 over 7 R3 plus R1 plus R1. I will multiply this leading one by -4 over 7, adding to this one to convert this one to 0. I will multiply my -13 over 7, adding to this one to convert this one to 0. So here, 0, 0, 1, this one same. Multiply the third row by -4 over 7. -4 over 7 times 0 plus 0 is 0. -4 over 7 times 0 plus 1 is 1. -4 over 7 plus times 1 -4 over 7 plus 4 over 7 is 0. Okay. Same for the first row. -13 over 7, row 3. -13 over 7 times 0 is 0 plus 1, still 1. -13 over 0 over 7 times 0 is 0 plus 0, still 0. -13 over 7 times 1, -13 over 7 plus 13 over 7 is 0. So now we have reduced row echelon matrix. Reduced row echelon matrix. First, I convert to row echelon matrix, then I continue until reduced row echelon matrix. Finally, we need to find the rank of a matrix. You can find the rank either from row echelon matrix or from reduced row echelon matrix. We need to count how many leading one you have. So here I have 3 leading ones. Same if you are using the reduce, you still have 3 leading ones. So the rank here, the rank of A equal to 3. How many leading one you have? How many non-zero row you have? This is the rank of the matrix. But you cannot find the rank directly from the beginning because this is not in row echelon matrix. To find the rank, you have to convert to row echelon matrix or to reduce, but cannot find directly. So after you find the row echelon matrix, you can find the rank, which will be 3. Which will be 3. Okay. Now we need to learn how to find the determinant of the matrix. How to find the determinant of the matrix, or sometimes we denoted it by this one, A, between two lines, or det A, or we can make it det A. Means that this one or this one, we mean that we are talking about the determinant of the matrix. Okay, if you have 2 times 2 matrix, 2 columns, 2 rows, then the determinant will be A times D minus B times C. A times D minus B times C. So this is if you have 2 times 2 matrix. 2 times 2 matrix. For example, if I need to find for 2, 3, 4, 1 matrix, the determinant here will be 2 minus 7. Sorry, 2 minus 12. Which is minus 10. Which is minus 10. So simply you need to multiply minus this one. Okay, if you have a 3 times 3 matrix, okay, this one you have 2 methods to find the determinant. Okay, this is the first method, but this one only for 3 times 3 matrix. If you have 4 times 4, 5 times 5, you cannot apply. You can apply only if you have 3 times 3 matrix. 3 times 3 matrix. Okay, what we need to do here, if I have a 3 times 3 matrix, A11, A12, A13, A21, A22 until we have A3. So this is 3 times 3 matrix. We will repeat the first 2 columns. The first column I will repeat here. The second column I will repeat here. Then I have 3 diagonal here and another 3 diagonal in the opposite direction. So you need to multiply the first diagonal, multiply the second diagonal, multiply the third diagonal, and add, minus, multiply here, multiply here, multiply here, so minus the addition of the other 3. So you add the multiplication for the first 3 diagonal minus the multiplication of the other 3 diagonals. So this is one method. Or this is another method for any n times n matrix, which means 3 times 3, 4 times 4, 5 times 5. You can find the determinant using what we call it the minor and cofactors, using the cofactors of the matrix. So let's learn what is the meaning of the minor of the matrix, how you can find the minor of the matrix, and then how to find the cofactor of any element of the matrix. Okay, consider we have this matrix 3 times 3, A11, A12, A13, A21, A22. This is 3 times 3 matrix. I need to find the minor 1, 2. The minor 1, 2. So it means that the minor related to the first row, second column. 1 is the row. 2 is the number of the column. So first row, second column, 1, 2. This element. I need to find the minor of this element. So I have to cancel the first row, cancel the second column. 1, 2. First row, cancel. Second column also cancel. So the remaining is 4 numbers, or the remaining numbers is the minor M1. A21, A23, A31, A33. Now I have a determinant by 2 times 2 matrix. So we need to find this determinant. A21 multiplied by A33 minus A31 multiplied by A23. Okay. For example here, I need for this matrix to find A11 and A13. The minor of A11 and A13. So to find the minor for A11, I need to cancel. I need to cancel the first row, the first column. 1, the first row, another 1, the first column. So the remaining minus 1, 3, 4 minus 5. So it is equal to minus 1 minus 5 is 5, minus 3 times 4 is 12, which is minus 7. Minus 7. Now I need to find A32, minor of A32, the minor of A32. I need to find the minor 3, 2. Means that you have to cancel the third row and second column, this one. So the remaining 1, 2, 0, 3. Cancel the third row, second column. So 1, 2, 0, 3. So the multiplication will be 3 minus 0, which is 3. Which is 3. So the minor means you have to cancel the minor of any element, cancel the row and the column of that element. So the remaining, it will be 2 times 2 matrix. Find the determinant. It will be equal to the minor. Okay. The cofactor, it is equal to the minor, but multiplied by minus 1 I plus j. Means that if I and j, the addition is odd, the cofactor will be the minor multiplying by minus 1. If the addition even, the cofactor and the minor same. Okay. I need to find the cofactor for the given matrix, C23. First, I need to find the minor 2, 3. I have to find the minor. Okay. The minor, I have to cancel second row with third column. So the determinant 1, 4, minus 1, 9. So it will be equal to 9. Minus 4 will become plus 4, which equal to 13. Which is equal to 13. 9 minus 4 equal to 13. But I need not the minor, the cofactor. I need C, 2, 3. So it will be equal to minus 1, 2 plus 3 for the minor. Okay, so minus 1 to the power 5 is minus 1. So minus 1 to the power 5 times the minor, which is 30. So the answer is minus 30. The answer is minus 30. So this is the cofactors 2, 3. So this is the minor. The cofactor is equal to the minor multiplied by minus 1. We need to add to the power, adding these two numbers, 2 plus 3. So minus 1 to the power 5. Minus 1 to the power 5. So the cofactor is minus 30. Okay. We need, for example, 7.4, finding the cofactor A11, A31. Okay, here. Because we already find the minor seed. M11, M31. So we need to find the cofactor. C. Okay, we need to find C11. Okay, C11 will be minus 1, 1 plus 1, minor 1, 1, which is equal minus 1 to the power 2. Okay, minor 1, 1 is minus 7. Okay, minus 1 to the power 2 is 1 times minus 7 is minus 7. So the cofactor C11 equal to minus 7. Because the square here will cancel the negative. The square here will cancel the negative. Now to find the cofactor 3, 2, it will be equal to minus 1, 3 plus 2, then the minor 3, 2. So minus 1 to the power 5. M32 is 3. M32 equal to 3. So the answer is minus 3. Minus 1 to the power 5 is minus 1. Times 3 is minus 3. So this is the cofactor. The cofactor equal to the minor multiplied by the negative 1 to the power. This power is the adding of these two numbers. 1 plus 1. If the addition is even, it will be cancel the negative. If the addition is odd, the negative you still have. You still have the negative. You need to multiply minor 1 and negative 1. This is how to find the cofactor. Now I will use the cofactor to find the determinant of the matrix. To find the determinant of the matrix. So how to do this one? You need to choose any row or any column in your matrix, then find the cofactor of the elements in that row or the cofactor of the elements in that column you choose. Okay, here I have a 3 times 3 matrix. I need to find the determinant of this matrix. I will use two different methods to find the determinants here because this is 3 times 3 matrix. So for this example only, I will evaluate the determinant using the two method for 3 times 3. Okay, determinant of A here, because this is, but the first method only if you have a 3 times 3 matrix. You can use this method. 4, 2, 1. I need to find the determinant here. 2 minus 6. 3 minus 7, 5, 0. Okay, the first method you can repeat the first two columns. 2 minus 6, 5. You can repeat only the first two columns. So 4 minus 2, 7. I repeat it here again. 2 minus 6, 5. I repeat it again here. Now you can multiply. I have 3 diagonals. This is the first one. This is the second one. This is the third one. So 4 times minus 6 minus 24 times 0 is 0. 2 times 3 is 6. Minus 7 minus 42. 1 times minus 2 is minus 2. Times 5 minus 10. So this is the first 3 diagonals. This is the first 3 diagonal. Then you multiply by another 3 diagonals. You can multiply by this one, this one, this one. Another 3 diagonals in the opposite direction. So minus, okay. 2 times 2 minus 4 times 0 is 0. 4 times 3 is 12. 12 times 5 is 60. 1 times minus 6 minus 6. Minus 6 times minus 7 is plus 42. Plus 42. So first I multiply the first three diagonals. I repeated the first two columns. Then I have three diagonal in this direction, three diagonal in the opposite direction. Multiply the three diagonals here. 4 times 6 minus 24 times 0, 0. 2 times 3, 6 minus 7 minus 42. 1 times minus 2 minus 2 times 5 minus 10. So this is the first thing. Minus the other 3. 2 times minus 2 minus 4 times 0 is 0. 4 times 3, 12. 12 times 5 is 60. 1 times minus 6 is minus 6. Times minus 7 is minus 42. So here we have minus 42 minus 10 is minus 52 minus 60 plus minus 102. 60 plus 42 is 102. So the answer is minus 154. 152. So this is one method how to find the determinant. This is one method how to find the determinant of a 3 times 3 matrices. You can, but this method only can be applied for 3 times 3 matrix. 4 times 4 cannot. So you have another two columns here, 3 diagonals minus the other 3 diagonals. Or you can using the cofactor. This method is applicable for any n times n matrix. So the another method, it's right here. 4 to 1. I need to find the determinant. 4 to 1. Then minus 2 minus 6, 3. The third one, minus 7, 5, 0. Okay. Now I will choose any row or any column. Choose any row, or you can choose a column. But you can choose a column, you can choose a row. Usually you can choose the first one. It's up to you which one you choose, but usually we use the one that have 0. For example, the third row. You can choose here the third row. So I will work now for the third row, for this one. You can choose third column also can. Then I will evaluate the cofactor for each element here. This element is coming for, this element is coming for the first row, third row, first column, sorry. So this one is on third row, second column. Okay, so I will have minus 7, the cofactor 3, 1, plus 5, the cofactor 3, 2. The determinant will equal to minus 7 cofactor 3, 1 plus 5 cofactor 3, 2 plus 0 cofactor 3, 3. So this one cancels because multiplied by 0. So to define the determinant, you need to find the cofactor 3, 1 and the cofactor 3, 2. Okay. The cofactor 3, 1 the cofactor 3, 1 is equal to minus 1, 3 plus 1 minus 3, 1. Okay, minus 1 to the power 4 is 1, so it is equal to 1 multiplied by the minor. Minor 3, 1, you have to cancel the third row, first column. So the remaining is 2, 1 minus 6, 3. 2, 1 minus 6, 3. So 2 times 3, 6. Minus 6 times 1 is minus 6, so plus 6. So 6 plus 6 is 12. Now we need to evaluate the cofactor 3, 2. I need to evaluate the cofactor 3, 2. So this will be equal to minus 1. 3 plus 2 minus 3, 2. Which means minus 1. Now the cofactor 3, 2, you need to cancel the third row, second column. So 4, 1 minus 2, 3. 4, 1 minus 2, 3. So it will be minus 1. 4 times 3, 12. Minus 2 plus 2. So minus 14. Minus 14. So I will take these two here. Minus 7 multiplied by 12 plus 5 multiplied by minus 14. So the answer should be minus 154. Minus 154. So this is the second way how to find the determinant. Either for 3 times 3 matrix, you can use this method or use the cofactor method. Choose any row or any column. Here I choose the third row. Why? Because I have 0 here. So I can reduce the calculation. So the third term will be cancelled. So minus 7, the cofactor for this number, plus 5, the cofactor for this number. This number is the third row, first column. This one is the third row, second column. So you need to find the cofactor 3, 1, the cofactor 3, 2. The cofactor 3, 1 equal to minus 1, 3 plus 1, the minor. Okay, minus 1 to the power 4 is 1. The minor 3, 1, you need to cancel the third row with the first column. So the remaining is 2, 1 minus 6, 3. So the answer is 12. The cofactor 3, 2, for element 5, you need to cancel the column that having 5 with the row. The remaining is 4, 1 minus 2, 3. 4, 1 minus 2, 3. So 4 times 3 is 12. 12 minus 2 plus 2. So the answer is minus 14. So substitute here, minus 7 times 12 plus 5 minus 14. The answer is minus 154. If you try using this column, also can. Here I need to find the determinant of P. The determinant of P. Okay. Let's 157 minus 3. Okay, I need to find the determinant of P. 157 minus 3, 0, 4. 1, 0 minus 3. You can use the first method by repeating the first two columns and multiply the diagonal, or you can use the cofactor method. Here you can use the cofactor because I have this column here having 2, 0. So we can work for the second column. So I need to multiply. This is be equal to 5 the cofactor first row, second column, plus 0. The cofactor second row, second column, plus 0. The cofactor third row, second column. But this one will be cancelled. So the only that I need to evaluate the cofactors 1, 2. So the cofactor 1, 2 equal to minus 1 to the power 3. Now cancel this row with this column. So the remaining is minus 3, 4. 1 minus 3. Okay. Minus 1 to the power 3 is minus 1. Minus 1 to the power 3 is minus 1. The minor here, minus 3 is 9. 9 minus 4. So it will be 5. Minus 5. It will be minus 5. So it means that the determinant will be 5 minus 5, which is minus 25. Minus 25. So the determinant of the matrix B is minus 25. By using the second column. So I have to enter 0. It's okay. So I need to find 5 multiplied by its cofactor. By its cofactor. 5 is located in the first row, second column. So the cofactors 1, 2. First row, second column. So I need to evaluate this cofactor. So how to evaluate this cofactor? Minus 1 to the power 3. 3 is 2 plus 1. The minor 1, 2, which means you need to cancel the first row, second column to find the minor. So minus 3, 4. 1 minus 3, which become minus 5. So 5 times minus 5 is minus 25. Also for this method, you can try the first method. Also the answer should be minus 25. You can choose any other row or any other column. The final answer should be minus 25. Should be minus 25. Okay. Any question?